Learning goal 49, we're going to be moving back towards a little bit more algebra, and we're going to be taking a look at patterns and how do we interpolate or extrapolate a pattern. So the title here is predicting using interpolation and extrapolation, and that just represents on how can we kind of use a pattern and decide go above or in between and find values in a pattern. So let's take a look at a little bit of prefix to start here. Patterns are often used to describe a set of numbers, or a set of numbers. We could also use patterns to describe a set of shapes. I'm sure you've used those in the past where you've taken a look at a set of shapes and then figured out what shape comes next or what color comes next or whatever the case that is. Okay, that's a pattern. The pattern will usually follow a set of rules, and by continuing that rule or pattern, the result can be found. So we are finding that kind of that next value, or looking at the pattern and trying to find the next result to that pattern. Let's take a look at this pattern of tiles. Here we have the first three figures that are drawn out. Each one is like a bit of an I shape, where we have the yellow blocks on top and then a red block in between. The second figure has two red blocks in between. The third one has three red blocks in between, and we can continue going on and on and on about that. When we take a look at a pattern, what we're going to look at is how is something increasing or decreasing and how to find that next value. So let's determine the number of tiles in figure 6. Well, let's start off by looking at figure 1, and we count up there. We have 3 on top, 3 on the bottom, and then 1 in between, so that is a total of 7 tiles. Number 2 has 8 tiles. Number 3 has 9 tiles. Right? That's the only figures we're given. Now we have to try to extrapolate to determine what is our next 3 values going to have. Well, 4, we can probably guess, look, we're going up by ones. So 4 is going to be 10. 5 is going to be 11. And in figure 6, we're going to have 12. In figure 6, we're going to be using 12 tiles. Again, there'll still be the 6 yellow ones that we're using, and then there'll be 6 red ones that we use as well. Now, while it is possible, okay, to draw out the remaining 3 figures, we could draw it out, or we can even visualize those 3 figures. Following the pattern in the chart is simpler, and will take up, number one, a lot less, take up less paper. I'm gonna put that on there. And maybe a little bit more specific to everybody here is it's going to take a lot less time. We can take a look at the pattern and see how much it's going up by each time, or we can take another pattern, see how is it going down each time. Let's take a look at another pattern. A banquet hall has small square tables which hold 1 person per side. Okay, so we can see that in the diagram right here. The tables can be pushed together to create larger tables where more people can be sitting. Now, let's take a look at the first 3 tables here. I'm sorry, the first 3 pieces of our diagram. The number of people sitting at the first one is 4, 1 person on each side. If we push 2 tables together, you'll notice that 2 of the sides can't have a person because they're joined, and so we only end up having 6 people at that table. In the third one, we're going to have 8 people in that table, and you'll notice that we're continuing to go up by 2s. So how many people could we sit around 5 tables? Well, let's continue this pattern here. If we're always going up by 2s, this will be 10. Then 5 will be 12. And we could still do 6, and that's going to be 14. Okay, so we can keep on going up. We can see that 5 tables, okay, I'm going to put that in there, is 12 people. So if we have 5 tables pushed together in a big long row, we're going to be able to put 12 people at those tables. But if we start going bigger numbers, so things like 10 or 25, okay, we're going to need a much bigger chart or a lot more diagrams to come up with that. Okay, we could draw out 10 tables and then figure out how many people can go there. Or what we can do is, again, use this table or another value or another way here. To find the higher values, a longer chart could be drawn, or an equation can be thought up. So I'm going to put it here in brackets, derived. Okay, derived means that we're coming up and we're determining what the equation is going to look like. Okay, so we can keep on going, a bigger table. If we want to get to 10, we keep on going, right? So number 7 would be 16, number 8 would be 18, number 9 would be 20, and so 10 would be 22. There we go. But how do we get 25? Well, that's a much bigger pattern that we would need to go through as well. So I'm going to put 22 here as well. Okay. Can we figure out a pattern that we can use a bit of an equation to solve for? Well, to create an equation, what we're going to do is we're going to determine what is constant in each diagram. And we're going to do more of this in a later lesson as well, but we're going to take a look right now at how can we come up with an equation. This value is going to be added or subtracted in the equation. Okay, we could also consider this to be the starting point, which in essence is going to be when our initial value is 0, what's going to be our starting point. Okay, now the first, so that's what we're going to look at. In this case here, well, we know that there's the blue person and the green person here, blue person, green person, blue person, green person. They're constant. They're in every single one. Okay, whereas the other sides of the table, we're always adding 2 every time. So in this case here, our constant would be 2. Okay, our constant is 2. Now let's go past that and let's take a look at how are things changing in our table. The first column of our table is called the independent variable. Okay, as it is changing in the sequence. Okay, so the first column is independent. It's going up by ones. Okay, figure 1 or 1 table, 2 tables, 3 tables. In our previous one up here, we had figure 1, figure 2, figure 3. Okay, that is our independent variable. It's changing, and really, in essence, it's going up by a constant rate. This is usually what we're going to consider to be our x value. Okay, so we usually consider this to be our x value. The second column is our dependent variable. Okay, as it changes due to the adjustments in the first column. This is usually our y. So you'll notice here, for every table we add, we're going to add 2 more people. Extra table, 2 more people. Extra table, 2 more people. We took away a table, 2 less people. Okay, so that's how it's going to change. This column right here is dependent on what we do in x. What we're going to do to find, to continue to determine our equation is we are going to find the difference between each row in the dependent variable column. Okay, and this is going to be multiplied to the independent variable to solve for the answer. Okay, and we're going to go through a little bit of how this works here to come up with an equation. But we notice here that in every case, in every one of these cases here, okay, so from 2 to 4, we are adding 2. And then between 6 and 8, we are again adding 2. And you can probably see the pattern that's forming here. We're always adding 2. So what that means is that we're actually going to multiply the number of tables by 2. Okay, so what we're going to do is to create our equation, so the number of people is going to equal the number of tables times 2. Okay, and then we need to add on our constant. Okay, our constant in this case. Okay, so we do the number of tables times 2, and then we add our constant. We said our constant was 2. Okay, that's what's not changing. We're never changing those two ends. We're only changing what's in between. So we are going to always add 2. So what this could look like, and I'm going to put some variables here in this case. Okay, the people sitting, I'm going to call this to be y, because that's going to be our dependent variable, and the number of tables is going to be x. And so we're going to have, we're going to not go quite so far down there. So number of people is y is equal to 2x plus 2. So the number of people is equal to 2 times number of tables plus 2. So if we do 5 tables, 2 times 5 is 10 plus 2 is 12. That's what we found. If we do 10 tables, 2 times 10 is 20 plus 2 is 22. If we do 25 tables, and we'll put this into a quick little equation here, y is equal, whoops, y is equal to 2 times 25 plus 2. And if we do this, y is going to equal to 52 people. And so with 25 tables, we could have 52 people at those tables. Now, I'm not going to give you an assignment at the end of this video. We're going to work through the next video, and then we're just going to do the entire assignment in one shot. So please move along to the next video, and we're going to be taking a look at how to interpolate as well. This is called extrapolation. Okay, so we're extrapolating, we're finding a number past. We're going to interpolate as well and use interpolation to find numbers in between.